All right, so here we are looking at this problem about a mirror, and we're trying to see if A and B can see each other in this mirror. So I'm going to start just by sketching a triangle. So one thing to do is draw a line straight to the wall, and then from A to the mirror on this angle, and then from B to the mirror, same idea, and then here. So this is how the light would have to bounce. So we know from the law of reflection that if this is going to work, this angle here has to be equal to this angle. And you might be able to tell from the diagram whether that's true or not, but we're not going to trust our diagram. We're going to mathematically show this. So we have to show these triangles are similar. If they're similar, then the angles will be the same and this will work. So what do we have here? A to the wall is a distance of 19 units. And A along the mirror is 30. And B to the wall is 7. And this is 29. So if these triangles are proportional, if they're similar, then these angles will be the same. So a really simple way to tell if they're similar is, first off, this is the right angle, is to just compare their sides, compare the ratios of their sides, corresponding sides. So the easiest way to do that is look at the wall side, because the wall side is the same on each one, like this is the corresponding part of the triangle, compared to the distance to go into the room. So the wall distance divided by the room distance. So for the left side, 30 divided by 19, we're going to compare that to 29 divided by 7. And without even using a calculator or doing anything, hopefully you see that these ratios are vastly different. This one's going to be about 1.5. This one's going to be about 4. So if these ratios are not the same, then they will not see each other. A's ray, the ray that comes from A is going to bounce off at some sort of angle like this. And the ray that comes from B is going to bounce off much shallower and go sort of like that. So the rays of light will not reach each other because these ratios are just so different. So in order for A to see B and B to see A, the ratio of each triangle, again, the wall distance divided by the room distance, has to be equal or very close to equal. So for example, if this distance were 60 and this distance were 38, then this would work because 60 divided by 38 is the same as 30 divided by 19. And so that would work. Obviously the scale this isn't to scale, but that would end up working. So that's pretty much all it is. You're trying to prove if these triangles are similar, and if they are, then they can see each other. So that's it. Until next time, I am Derek Genova. Have a delightful day.